division of complex number. In this lesson we are going to discuss how to divide complex number. So before we get to division, we have to discuss two facts here. The first fact is, as you know, multiplication is inverse operation with division. So we have to pretend that a over b is the same as a times 1 over b. Okay, this is one of the facts. The second fact is conjugates. We have to discuss about conjugates. So if you have a line here, okay, x and y axis, so let's represent a function, complex number here. So let it be that complex number goes x units to the right, okay, x unit to the right, and y units upward. So this is the position for the complex number z, which is x plus yi. So if we reverse the imaginary part, all right, so which means let it be, it's the second complex number, our complex number. The second one is, it goes again x unit to the right, all right, and y units down. So this is the new position for the second complex number. That will be x, okay, minus yi. Okay, the value of y here is in the negative y-axis. Therefore this is called z bar, which is called conjugate. Okay, conjugate for z. Okay, conjugate of complex number. So for example, if I give you z is equals to 3 plus 2i, its conjugate z bar is going to be z minus 2i. Just changing the position of y. Again, if I have a complex number, let it be z is equals to 5 minus 3i, its conjugate will be, okay, its conjugate will be 5 plus 3i. In this case, it is found in the fourth quadrant. Okay, now it goes to the first quadrant. In this case, it is in the first quadrant. Okay, it just move it to the fourth quadrant. Okay, so by keeping x constant. Okay, this is very important. So let's move on to the division. Okay, let's have two complex number here. Okay, z1, which is a plus bi, and z2 is equals to c plus di. Okay, let's divide this one. z1 times z2. As you know, that in real number, especially when you rationalize irrational number, for example, the square root of root 2 plus 1, if you remember, so you have to multiply by rationalizing factor, or by the opposite of here, by the opposite of the denominator, which means root 2 minus 1. Okay, root 2 minus 1. This is a rationalizing factor. The value is 1. If you multiply any number by 1, okay, the answer is the number itself. No change on the value, of course. But the point is, we want to change this we want to change this irrational number to, okay, rational number. It's called a rationalization. So we do the same thing here, kind of similar concept. All right, so a plus bi, okay, over c plus di. So multiply by its conjugate. Okay, of course you have to multiply this by 1. So this one is the same as a plus bi over c plus di. That one is the same as c minus di over c minus di. This one is a conjugate of this one. So when you divide, of course, that's the same as 1. Okay, so now let's directly multiply. Okay, distributes the value of a and d, a and b to c and d. All right, so this is the same as a plus bi, c minus di, c plus di, and c minus di. Good. So let's just directly multiply. Okay, so this is the same as AC, okay, AC, and minus ADI plus CBI minus, this is direct multiplication, BDI squared, which means I distribute. Do the same thing here. C squared, okay, minus CDI. I do the same thing here, okay. That goes to CDI and a minus D squared I squared. Okay, so this is the same as AC. I think this, okay, AC minus, all right, so you have AD and minus AD. You can take AD as in common, maybe minus CB into I. Okay, so now this I squared become minus 1 if you multiply that by negative, so it goes to BD, okay, over, now you have C squared, but this middle value becomes 0 because they are equal and opposite. So minus D squared times I squared is minus 1. All right, so this is the same as AC, okay, AC minus, no, AC plus BD minus AD minus CBI. Okay, okay, CD into I over, okay, you have here C squared plus D squared. Okay, this will be the value when you operate an expression. Therefore, when you calculate and finish this up, this will be the result. Okay, so let's see with the examples. Okay, let's see with the example. 1 is equals to 2 minus 3i, and Z2 is equals to 1 minus or 1 plus 2i. Just pause the video and try by yourself first. Z1 divided by Z2. Okay, so Z1 is 2 minus 3i and Z2 is 1 plus 2i. So multiply by its conjugate so that we will get 1 minus 2i, okay, and 1 minus 2i in both cases. So let's just directly multiply. 2 times 1 is just distribute 2. 2 times minus 2 is minus 4i. Okay, so the next is let's multiply with 2. Okay, let's use this. 2 times 3 minus 3 times 1 is minus 3i, and when you multiply with minus 2i again, that goes to 6 plus 6i squared over. So do the same thing here. When you multiply 1 by 1 minus 2, that goes to minus 1 minus 2i. Okay, when you multiply this, that goes to 2i, and finally when you multiply this, minus 4 minus 4i squared. Okay, so this is the same as, okay, let's move on here. This is the same as minus 7. So when you combine this, minus 7i, and then this is going to be minus 6, okay, because I squared is the same as minus 1. So this is the same as, again, this will be 0, right? Minus 2i plus 2i is 0. So you have 1 minus, but this I squared makes it plus, all right? So that's going to be plus 4, okay? So finally we come up with minus 4 minus 7i over 5. And this is the same as minus 4 over 5 minus 7 over 5. So the real part is minus 4 over 5 and the imaginary part is minus 7 over 5.